So this last lesson in Unit 6 that we're going to do is over graphs. So radical graphs. All right, so I went ahead and I graphed the parent function for the square root graph and for the cube root graph. So if you guys remember about parent functions, they're going to be the most basic function without any addition or subtraction or anything. So the square root of x is the parent function. So all these numbers that you plug in, you just find the square root. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. That's why the graph looks like it does. And so what I'm going to have you guys do today is to tell the domain and range of these functions. So the endpoint of the parent function is this point right here, and so it's at 0, 0. And then the domain describes all the x values where you have something graphed. And so the graph starts at 0, 0 and goes forever to the right. So that's going to be all the x's that are greater than or equal to 0. And then for the range, they're talking about from bottom to top. So it's the bottom y value, like the lowest it goes, 0. So your range is that all the y's greater than or equal to 0. All right. And then for the cube root function, I always tell my students it kind of reminds me of a snake for some reason. I don't know why. But on the cube root function, the turning point, which is going to be this point right here, if there's no shifting, it's at 0, 0. And this one has an arrow pointing to the left and an arrow pointing to the right. So what do you think that means for the domain? It's all real numbers. And then we technically have an arrow pointing down and an arrow pointing up. So the range is also all real numbers. So on a cube root graph, it's super easy to find the domain and range. It's just all real numbers. Now the square root graph, the domain and range changes from problem to problem. All right, so we're going to review some transformations of functions. This is something we learned kind of at the beginning of the year. We've reviewed it a little bit, but it's good to do it. Hopefully, the more you do it, the more it'll stick with you. But this is like the basic form. H, what's added or subtracted on the inside, is going to be a horizontal shift. All right, so do you know what direction it is if you add inside, if that's going to go left or right? What do y'all think? All right, so adding inside is going to shift to the left, and subtracting inside is going to shift to the right. All right, and then this K over here that's added or subtracted outside is a vertical shift. And on the vertical shift, if you add on the outside, it's going to be up, and if you subtract on the outside, it's going to be down. Right? And then your turning point or your end point, depending on which type it is going to be at HK. All right, so the number in the front can do two different things. If that number in the front, which is A, is a negative, then it's going to be a reflection on the x-axis. So it'll take it and just flip it upside down. Right? And then if we look at that number and just kind of ignore the negative, if it's a number greater than 1, it's going to be a vertical stretch. And if it's a number between 0 and 1, it's going to be a vertical compression or shrink. Okay, so we are going to go through a few examples where we're just going to tell the transformations. All right, so for number 1, we have this subtraction on the inside. So subtraction on the inside is going to shift it. This is going to be that many units, so 7 units to the right, or right 7. And then adding on the outside is going to shift it up 2. You guys remember doing that? It's been a while. All right. And then for number 2, there's 2 things going on. We're multiplying by this number on the outside, which is these things right here. Since that number is greater than 1, it's going to be a vertical stretch. And then this minus 1 is this subtracting on the outside, so it's going to be down 1. All right. For number 3, we have 2 things again. So we have this negative, and then we have this plus 3. So the negative is this statement right here. If A is negative, then it's a reflection on the x-axis. If there's a negative in the front, it's going to be reflection x-axis. All right, what about that plus 3 on the inside? What do y'all think? Left, right, up, down? It's going to be left. Good. Okay. And then number 4 has 3 things. So we're multiplying by 1/2, we're subtracting 2, and we're subtracting 6. So multiplying by 1/2 is this situation right here. 1/2 is between 1 or 0 and 1, so it's going to be a vertical compression. And then subtracting inside is going to be right 2. Subtracting outside is going to be down 6. All right, any questions on those? Okay. Now, last class when I was teaching this, I said 5 and 6 are a little more difficult than those, but they didn't act like they thought they were. So maybe I'm wrong. It's possible. So on 5 and 6, we're going to write the function that has these given transformations. So I'm just going to call my function y. You can call it y or f of x or g of x or whatever you want to. And this one is a square root parent function. So I'm just going to go ahead and put the square root of x, because I know if it's a square root parent function, it has to have the square root of x. Right, this one is reflected across the x-axis. So the only way to reflect across the x-axis is to put a negative in the very, very front. Right, then shifted 7 units left. How do I do that? Add 7 inside, good. And then 1 unit down, minus 1 outside. So I guess if you know the rules, it's not that hard. Oh, I thought it was. Mm-hmm. How are you supposed to know the difference between like working them out and doing that? What do you mean working them out? Like only learning like the like to solve in? Yeah. All right, this one, if the directions say to describe the transformations, that's what you do. This is what they're asking you to do. And these aren't equal, like those ones we did before, it was like equal to 7 or equal to a number. These are just f of x is what they're equal to. So it's a little different. Okay, this one's going to be a cube root. So I'm going to go ahead and do cube root of x. Right, and then this turning point, which is like kind of like right in the middle of the function, is located at -2, 3, which means that what happened was this was shifted left 2 and then up 3. So you guys fill in what you think you would need to take the parent function of a cube root and shift left 2 and up 3, please. All right, so to go left, you're going to add inside, and to go up, you're going to add outside. Okay, so what questions do you guys have so far? Okay, so on these graphs, I took a lot of stuff off the directions, but all we're going to do is graph each radical function in the calculator and do a little sketch if you want to. You don't have to if you don't want to, but then we're going to identify the domain of the range. So a good portion of your test that we're going to take in a couple of days, the calculator does a lot of it for you. So I know on the test, there's 1 or 2 questions where you're given the graph and asked which one of these is the equation for the graph, and so you just check it in the calculator, or you can do it by the shifting. All right. So anyway, we're going to go to our calculator and type it in. If you don't know how to do square root or cube roots, you need to figure that out before Wednesday. Now that +5 is not under the square root, so you kind of move over to get out from under it. Do you guys know what this +5 would do to the parent function? Yeah, it's just shifted out of 5. So you kind of in your head can know what the graph looks like before you even do it. All right, I'm going to do a little sketch of that graph just for me because I want to talk about it. It doesn't have to be beautiful. But I know when it goes up 5, and then I have my graph that looks like that. All right, so don't forget that the domain describes all the x values where you have something graphed. So all the x values go from this point and then forever to the right. So what is that x value right there? Yes. So it's all the x is greater than or equal to 0. All right, what about the lowest y value? Very good. That's not terrible. All right, let's type in the next one, number 8. And that's a negative in the front. You can kind of tell I changed it a little bit. All right, there it is. So this one had 3 things that it reflected it upside down, so you can kind of tell it's upside down compared to the last one. And then it shifted right 1 and down 4. So what would that make that point be right there? -1, oh, sorry, 1, -4. All right, so your endpoint's there, and then it's upside down. All right, so our domain and range are going to revolve around the numbers 1 and -4. So for the domain, we'll use a 1, and for the range, we'll use the -4. So would you say that the x's where this is graphed are greater than 1 or less than 1? Greater than or equal to 1. What about the y's? Less than. So because -4 is the highest value it gets, it's from -4 and down. So y is less than or equal to -4. All right. And then the last one, the cube root graph, you're probably going to be able to get the domain and range of a cube root graph without looking at it. I just want to remind you how you get cube roots. So how do you get the cube roots? Math. You actually do math 4 on this one because that's always a cube root. But math 5 will work also. You just have to go back and do 3. All right, and this is a graph that looks like a snake. And it's going to keep going forever to the left and right and up and down. So anytime you're asked to find the domain of a cube root, it's all real numbers, and so is the range. So you technically don't have to graph those if you don't want to. But I do want you to be able to match a cube root graph on your test on Wednesday. All right, so your assignment is a